Guys, just let me know if I'm audible as well as visible. Looks like some audio problem. Checking it, guys. Just a minute. Okay, wonderful. I think wonderful. So today, guys, we'll be talking about our solution drivers. So the same thing which we were discussing the other day, so similar to a problem statement. So now today's agenda is primarily can understand then that this is the area through which the solutions are getting derived on. So we have to understand first the problem statement, and obviously when I say the solution drivers, right, so it's pure towards understanding how the things are working in terms of different industries. So when I have a problem statement, it is obviously subjective. I cannot have the same problem for every single industry. And that is where if my industry level problem statements are different, obviously the solution drivers also would be different. Correct? And that is what the prime objective of today's discussion is, to understand each and every individual problem statements of different industry level information, and then from that industry level information we'll be going in the solutions of each part. So that's pretty much what the agenda is for today. So let's keep on talking, and pretty much it's a live session, so I will be expecting people to interact. So any questions, anything at any point of time, so please do come up and let me know in the chat. So I'm monitoring the chat. Just quickly let me configure that as well. So as always, I'm more than happy to take the questions here, guys. Cool, great. So let's get started. As always, to start with, you know, my name is Arpit Jain, and the reason why, guys, because I really like data science, and data science is my passion, and I really love sharing my expertise with people, where I've been working with multiple industries for a number of years in the background in analytics field. And also along with that, I am a motivational speaker, so I do talk to students regarding their career, jobs, placement, so anything in general as well, you can feel free to talk, so we can always talk on that front. Cool, guys. So that's pretty much about me. Moving further, the agenda for today, as I was talking about, we'll first try to understand the industry specific requirements of my problem statements. So I'll quickly give you a brief of different industry level specifications of different requirements here, and we'll talk about this front. And post the industry level specifications, we'll talk about the solution drivers. So now once we have understood the problem statement, we'll try to go deep in each industries, and we'll try to find out what could be the potential solutions, and exactly who will be the person driving those solutions, right? So we'll discuss on this front, but let's try to first logically also understand when I say industry specific requirements. So what does it mean? So when I say industry specific requirements, I am talking about individual industry specific problems as well, right? So suppose that I'm working for a bank, I'm working for a finance industry. Do you think, am I bothered whether Virat Kohli will make a century today or not? Might be not. So my problem statement is confined towards what are my fraudulent transactions and what not, right? So industry specific requirements from finance point of view would be more towards what is more specific to my industry, more like a transaction frauds or risk assessments and all of this respective to my finance industry. Or at the same time, if I'm from a healthcare industry, my problem statement would be maybe whether I'm able to diagnose the disease at the right time or not. Right? How good I am with those diagnoses. So those could be my potential problem statements. Or when I'm from a logistics industry, like a supply chain or manufacturing as well, I'm more bothered towards now how optimally I have to keep on storing my available warehouse inventories. Could be one of my potential problem statements. So likewise, if I talk about different industries, obviously my problem statement keeps on changing. And if my problem statement itself is changing, yes, accordingly, the solutions also will change, because the same set of solution might not be applicable for every single industry. It's pretty much logical as well, right? Now, when I have different industries and when I have different set of problem statements, then comes the solution drivers. There are a certain set of people who are governing this entire program, which is an iterative process. So there's a set of data science team, technical team, the engagement managers. It's a process in the background, right? And that is pretty much what the agenda for today is. We're going to be talking about who are these drivers, who are these people who are prominently running these industry specific problems and providing a data related solution on top of them. So that is what the agenda is, right? And we'll be discussing on that part. Moving further, we'll try to understand each industrial perspective one by one. But before that, as always, a quote for you for the day for data science. So that which cannot be measured cannot be proven. It's a very, very famous quote again. So that which cannot be measured cannot be proven. So we always say that if I'm not able to prove something quantitatively, it cannot be, if it cannot be measured, it cannot be proven. So if I have to prove something, I have to make sure that it is also measurable. So by measurable, I mean quantified, right? I need to have a certain parameter or a certain metric in which I can now evaluate or I can judge, yes, this is what the relevancy of my analysis is, or this is what the performance of some specifications is, right? So I'm going to talk about something which is measurable, only that can be proven, and something which cannot be measured cannot be proven. And it is very valid in every data science industry. We always talk about a measurable and quantifiable results. We have to make sure that we have the measurable outcomes in which we have at least the hold of the things where we can say that, yes, this is the reason why it is better, or this is the reason why this is slightly not that great, right? So something which is measured can only be proven in data science. So moving further, let's try to understand the problem statement again. So we have been discussing around the problem statement in the last couple of classes as well. But a quick recap about this problem statement. So in the simplest form, a problem statement defines the pain point we hope to solve or the impact you hope to make with your work. Straightforward. So we're talking about the pain point here, guys. So pain point, that means I'm trying to understand what is the area which is still not that great right now from the industry perspective. So we're talking about the pain point which I'm hoping to solve for my business. And that is something which defines my problem statement. There is something which is not right at this moment, and we are trying to make this not right thing to a right thing. So pain point to a statement, to a problem statement we're trying to solve, the pain point we're trying to rectify, that's where the definition of my problem statement comes. And obviously, this statement should be clear, concise, and define a measurable outcome here. It should be 100% clear, it should be concise, and it should define a measurable outcome. So when I say clear, I should be 100% sure that yes, with this problem statement, I am going to get this output. There should not be any discrepancy. I'm trying to understand the problem statement which you're trying to solve, which is 100% clear, concise, and at the end, it should have a measurable outcome. Again, as I've told you, something which cannot be measured cannot be proven. So if I'm trying to rectify a pain point, if I'm trying to solve a pain point, so for that problem statement, I need to have a measurable outcome. I need to make sure that I ultimately have an evaluation strategy from where I can say that yes, this is the reason why, and this is what, if done, can solve the problem statement. So ultimately, what we are trying to answer in the question, it should answer the question like, what is the problem that you're trying to solve? So ultimately, when I say I'm trying to frame up my problem statement, that is where I'm going to say whether that question is able to answer this. What is the problem that you are trying to solve? So ultimately, we're trying to solve a problem which is standing in the industry right now. And obviously, creating a problem statement is an iterative process. We always improve our problem statement, correction statement as well. So, and again, as I've told you also before this, defining a problem statement is very crucial step, because if you do not have a clear statement, if you do not have the measurable outcome, if you do not have the clear result which I'm expecting from my solution, I will always get into a trouble later on stages. And we might not be able to identify the straightforward statement on day one, because again, from a technical point of view, I'm not expected 100% of the time to have the domain knowledge as well. What if the person coming from a telecom industry, do you think he cannot solve healthcare problem? He can, because ultimately he has the knowledge of data. I mean, data, by that I mean data science. So statistical concepts, the Python knowledge, machine learning knowledge, he still have the data science knowledge. But yes, he might not have the relevant domain level information might be required to frame up the problem statement. So for that, we have the subject matter experts who are working day in and day out in the industries respective to that workplace. So yes, data science people, they work hand in hand with my subject matter experts as well. So we can obviously keep on talking with subject matter experts and end up developing or defining the problem statement. So that is the reason why we say that it is always an iterative process. So we talk, we improve, and then we try to identify the right problem which is expected from us to get solved on. So that defines my problem statement, guys. Moving further, I'm trying to introduce you to different industry level problems which we generally solve from data science. So for example, banking. Let's try to first understand this. So when I say banking, so banking and the financial sectors, they are highly dependent on the data science solutions powered by big data tools. Let's try to understand this first statement. So, I mean, logically also it makes sense. Banking and the finance industry is very much data centric, very much number centric, at least, right? So many, I mean, second level transactions are happening. So bank does not have only one client. Bank has thousands and maybe lakhs or millions of clients, right? And every person is now making some or the other transaction every other minute, or maybe now every other second. So transaction level information, and when I have these many banking clients, I do have the demographic information and a lot of day-to-day transactions which are happening in and out of the bank and the accounts. It's very much data heavy. So data science plays a very huge role in banking and financial sectors. It's logical as well because it's hugely dependent on the numbers here. So the data science solutions, that means that the problem statements which we are trying to solve here by the data science solutions, this is powered by the big data tools. Now, why not normal tools? Why only big data tools? And what do we mean by big data tools here? Again, very standard problem. So, again, big data is a very contradictory term, I would say, or a misrepresented term as well, because big data definition is very referential. For example, if you try opening an Excel file with more than say 300-400 MB size, you might start seeing that Excel is crashing. It's not able to open the entire file because yes, Excel has certain limitations in opening the number of rows and number of columns. So for Excel, maybe 200-300 MB or 500 MB at the max is a big data. So big data means anything which is big or which is too bulky to handle, right? So for Excel as a platform, maybe 200 MB or 500 MB is a big data, too big data to handle. Similarly, when you talk about Python, some GBs. So, and then depending on the entire framework, the referential point, the big data definition will keep on changing. I mean, the referential size of the data would be changing likewise. But in transactional level information where we have every second transactions happening, it's very much data heavy. So here, the data science solution is pretty much handled by the big data tools. And the problem statement include risk analysis, risk management, KYCs, fraud mitigations, not many such problem statements. So big data tools are used to power the data science solutions, which might include risk analysis. So what profile and profiling of my customers, doing the risk analytics, risk management, taking some preventive actions based on the analysis results and advising the banking firms to take respective decisions for XYZ customers if flagged. Doing the KYC operations, fraud mitigation. So lot many sectors, lot many areas where the data science solutions play a very important role in my banking industries, and all of them majorly are powered by the big data tool components, right? So the large banks, hedge banks, stock exchanges, and other financial institutions use advanced data science powered by big data, artificial intelligence, machine learning for trading analytics, pre-trade decision support analytics, sentiment measurements, predictive analytics, and more. So majorly all of the financial institutions, whether it is small, big, stock exchanges, almost all of them, they are now in these days using the advanced data science tools and technologies, which include big data, artificial intelligence, machine learning for a lot many use cases. We talk about trading analytics. So we talk about forecasting of my stock exchange, stock values. So for example, if you would have heard of a graph, or I mean, wherever if you would have seen a graph, something like this. So I have then we have the stock prices. Suppose stock started from 0 and then we have a certain trend and then something like this. So if this is the trend of my, say, graph or the stock price with respect to time, so this till here, till this point, I have my original data, but with respect to this, I can also further extrapolate it with reference to my this data. So this extra point which got generated, that is called as forecasted values, forecast. So yes, I am going to use this results for my trading analytics. I'm going to have a mechanism which can be useful to identify the potential forecast of my respective prices of my stocks. Yes, trading analytics is a very common fact. We can do that. Pre-trade decision support analytics. So I know the trend is going like this. So I know selling the stock at this point is advisable or this point is advisable, or still I can wait till this point. So I have point A, I have point B, and I have point C. So I know that it is expected to go till point C. So there is no point of selling the stock at point A. Not advisable. So I would rather wait for say 1 month or say 3 months or whatnot. And expectedly, I am expected to have this growth. So I will be expecting point C. Pre-trade decision point analytics comes into picture. Sentiment measurements. Yes, very handy. So we talk about, because the stock markets and the other things are very much affected by day-to-day activities. Like for example, if there's a new tweet coming up for any industry or any news which comes up for any profile, and that is going to distort or affect the prices of my stocks. It does happen, right? So, and that is where sentiment and measurements comes into picture. We talk about how we can use these sentiment measurements to identify the right set of features, the right set of context at the right time, so that we can analyze the sentiments of my people for that particular product or the brand. Again, banking level problem statement. Predictive analytics, we talk about identifying whether it's a fraud transaction or it's a non-fraud transaction, or identifying the prices of my stocks. So all the predictive level support, the sentiment measurements, decision point analytics, everything pretty much what covers around the banking sectors. Again, not limited to only these, but these are some prominent problem statements which a banking sector generally tends to solve. I hope it makes sense, guys. Then comes again very interesting industry, the marketing industry. So the marketing departments often use data science to build the recommendation engines and to analyze the customer behavior. So very good point, very good point. We'll try to understand this. So when I say a recommendation system, so marketing is what? You're marketing your product. You're making sure that whatever I'm marketing, that is getting consumed by my consumers. And who are my consumers? It is very subjective to my industry which I'm part of. So for suppose this marketing team is for the research and the development, or the marketing team is for sales, or the marketing team is for any product whichever I have, right? So accordingly, whatever my audience is, how convincingly I'm able to absorb the information. That's where the capability of marketing team comes into picture. So in general, the marketing team department often use data science to build the recommendation system and to analyze my customer behavior. So, and we have been talking about recommendation system in other use cases as well. So when I say I have, say, Netflix or Amazon, you have already seen the recommendations on their websites. So Netflix, we have something like recommended for you depending on your past history, or this is what I as a platform recommend you to watch. Or Amazon also, the moment you start browsing something, you start getting recommendations recommended by Amazon depending on your past search history. You may like this. So all of these is pretty much part of my recommendation system. So what happens with this recommendation system is we are now going from public to private or personalized marketing. So instead of creating big hoardings or instead of creating some mass level marketing, I am only going to show, or I am only going to target the people with the content I have where I have the maximum probability. So that's where the recommendation systems comes into picture. It is very much personalized. It is trying to track every individual's behavior and the pattern and the usages details, and accordingly identifying the right set of offering which must be given to that user to have the best consumption rate. So recommendation system, it is pretty much applicable in multiple other platforms, but the marketing team, the marketing industry is what primarily focused towards doing a personalized marketing, right? And also, depending on my customer behavior, depending on your behavior, you might have started seeing things on your day-to-day applications as well. Suppose if you're using the commute applications like Ola, Uber, or if you're using some food applications like Swiggy, Zomato, so they analyze your patterns and your behavior, and accordingly they might keep on sending you some recommendations as well. They might keep on sending you some profiled offers, right? Again, pretty much game of marketing industry. So the retail marketing process involves analyzing my customer data to inform business decisions and thus drive the revenue. Very, very statistical. So the marketing team here, the marketing industry, what happens, what they do is, the marketing team, they are completely involved in analyzing my customer behavioral data, and from that it is helping the business to take some right decisions, eventually move towards driving my revenue. So now when I say that I have a data point perspective of driving the solution, so I'm going to say that my consumer data, whatever I have, my ultimate objective is to analyze the patterns from this and then help the business. So for example, I'm going to give you a very straightforward thing. So if you would have gone to a supermarket to purchase any product, right? So I'm not sure if you have noticed, so the arrangement of my products is also a very smart analytical thought process. Things like, if you would have noticed, like simple thing, so you might observe bread and butter, or like milk and butter, they might have been closely kept together because these things go hand in hand. And if you go to the Indian supermarkets or anywhere else as well, towards the billing counter you might see a lot of chocolates they keep. So more like candies or like gums or some other bars as well. So they keep the chocolates closer to the billing counters. It has been observed that the selling of the chocolates and the gums are more, if they are more closer towards the billing counters. So all of these strategic business level decisions are pretty much backed by some analysis which is happening in the background. And what is this analysis primarily focused on? Analyzing my consumer behavioral, the consumer data patterns, which is driving my revenue here. So common data used in the retail marketing include the customer data, the product data, the sales data, and the competitor data. So all of this are equally important. When I say consumer data, that is where I'm going to get the demographic of my user. So consumer data, that includes age, phone number, address, gender, name, and whatnot. So all personalized demographic level information which generally user fills up a form and then they submit it. So that's my consumer level data. Then I have the product data. So I need to map for any recommendation to give, I need to map the user with a product. So I'm mapping whether the user 1 will buy the product 2 or not, something like that. So mapping between my consumer data and my product data, they both are equally important. So customer data, product data, they go hand in hand here. Post that, sales data, because this is according to which we will understand what data points to focus on. So whether I have to focus on product A or product B or product C, depending on my sales of my product. So sales data, competitor data, again, lot many information comes up here. So this is slightly little difficult to obtain as well, but if we have a leverage of my competitor data, it's going to play an important role to identify the right strategy for my business as well. So competitor data also plays a very crucial role in this case. So I hope that makes sense to people. Post marketing, now we're going to talk about finance and trading. Again, so finance departments use data science to build trading algorithms, management of my risk, and improve my compliance. And this includes data about the companies whose stocks are traded on the market, the trading activity of the investors and the stock prices. So this purely talks about the companies whose stocks are traded in the market and the trading activity of my investors, the stock prices. So daily ups and downs, and what is the selling point, how many units, how many stocks are getting changed at which point of time. So activities, daily activities or trading activities of my respective investors, and how the stock prices are changing accordingly. So all day-to-day ups and downs of my value points is pretty much what the finance and the trading industry look care of. And yes, often at time it has been observed the financial data is unstructured and messy because it is collected generally from different sources using different formats. So maybe I'm using Python on one platform and maybe doing some random analysis using some other platform on some other use case. So in different formats, like an Excel file, like an XML file or HTML file, so I might have different level of formatual errors as well, and the heterogeneity of my different formats which I have in the collected data set. So often at times it has been observed the data collected in the finance and the trading industry is very messy, and it could be in different format as well, because if you understand, we also talk about the financial trading industry is very subjective to news. Picking up text, maybe from a website or something. So this text has to be extracted from this website so that we can use this as part of our statistical references. So for this, I need to go to this website and extract the right information, because website will have millions of things. And I don't need all of these things. I need only 10-20 pointers which I have on this website. So technique to extract the right set of information from the website is called as web scraping. And that is where the collected form of different sources would be different. So it could be different. I mean, obviously it could be different. So web scraping, again, one of the technique which is very heavily used. And the moment I have different formats, it is going to get complicated. It is eventually going to get different results as well. So that is the reason why working on these different data points becomes a little heck of a thing to process it. But that's where the entire game is. Right? So moving further, human resources, HR. Yes, HR departments also use data science to hire the best talent, to manage the employee data and predict the employee performance. Can you imagine this? So non-technical people, the HR department, they are also using data science to hire the best talent. Think about this. So whenever you apply to the jobs, there are what? 1,000+ applicants. And do you think it is practically applicable to read these 1,000 resumes for a person? It is not for a single person. Even if I still have, say, 200 recruiters, yeah, they might read 5 newspapers, but then I'll be having the biasness of all of these 200 recruiters, which is again going to create problems. So how can we get this corrected? We have to understand what are my potential pointers here. So for this case, we have to find out the data points which are needed. So for this, yes, again, data science plays an important role. So automatic filtrations, trying to find out how this can be used. So finding the right keywords, doing the right set of processing of my resumes, the text processing pretty much defines my problem solving of HR department. Again, we talk about management of my employee data, so many data pointers every time we can keep on storing the database. So again, management of my employee data, predicting of my employee performance. Yes, if I have my best level information of my each employees historically as well, yes, I will be able to predict the employee performance as well likewise. So again, one of the very practical use cases, part of my human resources department. And the data scientist working in the HR will primarily use employee data collected from different data sources. It's pretty logical as well. So in HR field, the data scientist who is working dedicatedly or working in the HR will definitely involve the employee level data collected from multiple different sources, because to avoid the biasness of my information, it is always advisable to have the referential different sources of my data as well. And obviously this could be structured, this could be unstructured, depending on the method of collection of my data. So structured, unstructured, simple, pretty simple. So structured is nothing but table and rows format. And then we have unstructured, so the data which could be collected for HR department, it could be structured, unstructured, and also could be collected from different platforms. So also we might be using some fancy level informations in structured and the unstructured part as well. So doing some fancy web scraping or extracting data from different data sources, doing the manipulation, pre-processing my data, all of pretty much this comes under my unstructured analysis of my data point. Okay. So again, and this is what you have to always understand. So data is technically everywhere, guys, technically everywhere. And that is the beauty of getting into data science, that makes you fit for any role in any field, any different domain. Yes, there will be if and buts, there will be some other requirements, but you are technically eligible. You have the skill set to work in these domains. Okay. Moving ahead with this, we have one more industry. So logistics, again, very important industry in terms of the revenues, right? So in this point of view, again, logistics is one of the industries where it does play a very crucial role in terms of my clearance as well. So logistics and the operations departments, they use data science to manage the supply chains and predicting the demand. If I'm not able to meet the demands, how will I generate the revenues, right? So meeting and managing the supply chains, the logistical support, the warehouses, and at the same time predicting my demand. So I'm not overproducing anything, and at the same time I'm not underproducing anything. So logistical data science team would be more primarily focused towards understanding or forecasting the requirement of certain products in time, and accordingly how this can be further modified so that we can be better prepared. So logistics and operations department, they are going to use a data science to manage my supply chains activities and also forecasting or predicting the demand which I have. And the data scientists working in the logistics and the warehousing will primarily use data about customer orders, inventory, and the product prices. Again, very interesting. So when I'm trying to solve a problem statement in logistical industry, I have to be relevant with the respective data pointers. So I'm going to be talking about warehouses. Warehouses will primarily use the data about the customer orders. We talk about inventories. So apart from the customer orders, we also have to take care of the productions which is happening, right? So customer orders, tagging it with the respective inventories I have, updating the records, so product prices. So every single thing is what the technical data science team of logistical industry would be taking care of. And the data scientist will use data from sensors and IoT devices deployed in the supply chain to track the product's journey. Yes, so data scientists to capture the relevant data pointers for the logistical supports like the trucks and the other mid-size vehicles which is generally used for logistical support. They are installing the sensors, the IoT devices deployed in these supply chains, the logistical support to track the journey I have or my product's journey, how this is getting from one place to another and how it is getting used. So again, another format in which the data are collected using sensors, IoT devices, Internet of Things. So pretty much where logistical industry comes into picture. Now comes the very important part of understanding who drives these entire business solutions. So we have prominently three different type of industry level experts who drive these solutions. First, we are talking about business manager here. Then we talk about IT manager. And then we'll talk about data science manager. So these will be my prominent drivers or the people, the key resources who are actually running the show. Running the show means who are talking, taking the business, delegating the team members, and then ultimately coming to a final proposed results to the team. So business managers are the people in charge of overseeing the data science training method. People who are in charge of overseeing the data science training method, and their prime responsibility is to collaborate with data science team to characterize the problem and establish an analytical method. And data scientists may oversee the marketing, finance, or the sales department and report to an executive in charge of that particular department. So here what happens is the business managers, they are making sure that the ideology behind the problem statement is pretty clear. The problem statement is crisp, concise, and everybody is 100% sure of what problem statement we are going to solve and what is my desired outcome on top of this. So this is what the role of a business manager is towards. So prime responsibility is to collaborate with the data science team to characterize the problem, finalize the problem statement, and have checkpoint meetings to understand the progress and establish an analytical method, giving you the right set of potential solutions from a business standpoint of view, in which direction you should be proceeding and ultimately looking for the best result, which I'm going to find out. Post this, we have something called as IT managers. So these are the people who are primarily responsible for developing the infrastructure and the architecture to enable my data science activities. So they are primarily responsible for actually doing the technical on ground relevancy of the problem statements what we have. So we talk about developing of my infrastructure. So for a data science problem, we always talk about infra. Imagine a situation, you have for now a system or a laptop which is having say 16 GB of RAM. So you're having a laptop with 16 GB of RAM. Do you think it is possible to process an Excel file which is say 100 GB? No, it is not practically possible because I do not have the respective system or the infrastructure to solve, to process or to consume that data, right? So developing the infrastructure, developing the architectures of my entire solution, which block, where to connect, how to connect. So all of these minute level information from a technical standpoint of view, that's what IT managers take care of. And resource accordingly to ensure that they operate efficiently and safely by the IT managers. That's what they do. They may also be in charge of creating and maintaining IT environments for data science team. So basically, data science team, the technical on ground team, they are in touch with the technical support of the IT managers who are developing, deploying my infrastructure or the architecture, and both of them also could be to enable my entire data science activities if I do not have a right capacity of my solution. So capacity enhancements, capacity understanding, solutioning of my product, that is where the IT managers comes into picture, and they take care of the development, deployment of my entire infrastructure and the architecture of my system. That's where IT managers. So technical guys, technical managers, technical supervisors. Again, these names could vary from companies to companies, but primarily there will be a technical supervisor or IT manager who is taking care of the entire infrastructure, the ecosystem on which you will be actually solving a data science problem. And at last, we have the data science manager, more like a people manager. So people management. So these are people who are primarily tracking and supervising the working procedures of all data science team members. They also manage and keep track of day-to-day activities of the 3 data science teams, and they are team builders who can blend project planning and monitoring with growth terms. So basically, these are the people management people, people management managers who are doing the people management task of binding the multiple team members from a data science team into one single unit, and making sure that we are able to fully utilize the capacity of individual people for the usefulness of my business. So these are the people who are primarily tracing and supervising the working procedures of all data scientists, all data science team members, and they also keep on managing the track of day-to-day activities of my data science team. So now a quick question to people here whosoever is wanting to answer this. Do you think it is practically possible to become a solution driver on day one from after you pass out from a college? Do you think it is practically possible to start driving a solution? No, it is not possible. So the driver level jobs, like here in this case, the managers who are driving the solution, it is not ideal for a fresher. The freshers, for them, it is prime requirement to first understand the problem statement. If you understand the problem statement, you will be able to drive the solution also one day. But your prime objective should be to first understand the problem statement and then accordingly move towards the right direction depending on your path. Cool, guys. So this is what I wanted to cover. Any open questions, I'm more than happy to take it. But for that, thank you so much everybody for being patient and listening to me. So this is what I wanted to cover and intended to cover for today. Primarily focus around the problem statements and the key drivers and the solutions for the respective problem statements I have. Cool, guys. Any last moment questions, anything which you want to ask, I'm more than happy to take it. so we can take those questions, or else not, we are good to close. Cool, guys. So with this, thank you so much for being patient again, as always, listening to me. So we are meeting again the next day, so with a new topic, but we'll continue with our data science playlist. So we'll talk another day with a new topic, guys. Thank you so much, and have a good